So now we're going to wire a 555 timer so that the output, if it's already high, you press the button, it will go low. If it's already low, you press the button, it will go high. It can alternate. So we'll get to that. So we got the NE 555 right here. Micro A will work the same. If it has different letters in front of it, then there's a good chance it may have other properties you got to be aware of. So positive supply to pin 8 right there, VCC. Negative supply to pin 1 ground, and then we have the reset pin number 4 to the positive supply to disable it. It's waiting for a low input to force the output low and hold it there. As long as you have a low signal to pin 4, the reset pin, we are not using that in the circuit. We are also going to tie together pin number 2 and pin number 6. We want them to be looking at the same voltage in this circuit right there. And we will come to the rest of the circuit next. So now we're going to focus on the output. I want a red LED to light up when the output's high, and I want the blue LED to light up when the output is low. Of course, it doesn't connect directly to the positive supply, but close enough. So red LED is headed to ground. The short lead, the cathode. We're going to swap the position with the resistor, and I'm going to use a 1000 ohm resistor for both of the LEDs because that's what I got on the diagram. And the blue LED right there, the long lead, the anode, goes towards the positive supply. So I'm going to wire that right there. Again, I swapped the position with the resistors when it came to the LED, and we're going to use 1000 ohm resistor for both of them. So I got to come up to where the long lead, the anode, is for the red LED right there, and then go to pin number 3, the output. And then with the blue LED, we're going to do the same thing right there. Go to the short lead, the cathode actually this time, and then we're going to go to the output over there. So now we're going to bias a voltage when it comes to pin 2 and pin 6. They are connected together right there. We're going to put a 10K resistor to pin 2 and a 10K resistor to pin 6. The one going to 6 goes to the negative supply right there, and I got it backwards if you're looking at the color code, and the one going to pin 2 is to the positive supply. So these are equal value resistors right there. They're setting half of the supply voltage at both pin 6 and pin 2. Pin 6 is waiting for more than 2/3 supply voltage. Pin 2 is waiting for less than 1/3 supply voltage. Half the supply voltage is in the middle of there. So it doesn't change the output as long as you keep that half voltage of supply voltage across the two of them. Now we're going to focus on the circuitry that can force this to change from time to time. We have already a jumper coming to one side of the switch, going to where pin 2 and pin 6 connect, that spot right there. We come to the other side of the switch, so we will put a capacitor right there, and then we got a voltage that will change once I get the capacitor in there, and I close the switch. That changing voltage can be sent to those inputs. We will take a 10K resistor right there and go from the switch that is to the capacitor there, and then go up to the discharge pin number 7 up there. So it can discharge the capacitor through the resistor there. It's a 10 microfarad capacitor. It'll discharge pretty quick. It will also charge pretty quick when we add that resistor. So 10K resistor there between 7, the one we just plugged that resistor in, and the positive supply. So you can see that jumper going across. I have power turned off, so I don't have to worry about touching components. And that was in my hand in a way where I could not bend down. But I'm off a spot. Let's go up one more right there. And running into stuff right here. We're a little cramped. Definitely want the power off. So there we go. Wasn't sure how you could see it, so I made sure to look at the camera. So yeah, that should be our complete wiring. This should work. So now we're going to attach the power supply and see if it works. I'm going to turn the output off first, but we got the alligator clips. I'm going to clip them to these header pins. They make a decent connection. Better connection with better boards, but even with this cheap board where it's kind of loose connections, these don't do too bad. And so it's good when you're wiring stuff, have the power supply voltage off and then turn it on. And yeah, it looks like it prefers to start off being low right there, but as long as we wait at least a little bit, press the button, now the output is high. And the red LED is not very bright because I got a 1000 ohm resistor. I wired this up so that I could use a higher voltage. I think originally I had a higher voltage, and then I made another schematic with this 5 volts. Just because 5 volts is more common than the other voltages, probably when you're building 555 timer circuits. But it's that simple. You gotta watch your speed. As you can see, we got a bounce because you kind of gotta wait for the capacitor to change its voltage, definitely. So you don't want to go too fast, but you don't have to wait that long either. Looks like 2 seconds is plenty right there. But that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.